Okay, by now you know the drill. I bought a 3D printer for some hobby projects, then I bought another one. Now I'm designing and building a printed circuit board from scratch. Well, maybe not really from scratch. I designed everything and assembled everything, but I decided having circuit boards made by a vendor was easier and more likely to succeed than etching the copper clad myself. At least the enclosure for the thing is 3D printed. But what is the thing? It's an upgrade to the laser imaging rig I made in a previous video. This time it has 3 lasers and a circuit board to manage switching the lasers. More on that later. I'm old school, so I used a circuit design tool I've had on my Mac laptop for a long time. This tool is called fritzing. The forums are not very kind to it, calling it a toy. But I find it works very well for my needs. I tried driving the lasers directly from the microcontroller pins, but that did nothing. Instead, I need a switch in the form of a transistor, specifically a MOSFET. I tried driving the MOSFET gate directly from the microcontroller pin, and it also did nothing. So I found this circuit for a MOSFET gate driver using 2 NPN transistors. After quickly proving this on a breadboard, I started laying out the PCB design. I needed 3 channels, so I made 1 channel and optimized its layout before duplicating it. With a little inspiration from the auto routing features, I settled on this layout, so I sent it off to the vendor. What could go wrong? After a few weeks, the parts arrived, so I began assembly. After soldering everything in place, I confirmed one of the traces on the PCB was wired in such a way that the switch did not achieve its intended purpose of turning the lasers on and off regardless of USB power. That means they're on all the time when it's plugged in. I discovered this while waiting for the shipment to arrive and had a workaround planned. I would cut the copper trace and reconnect with a breadboard jumper. So I did that, but I accidentally cut one of the traces I needed to keep, which meant another jumper. When finally assembled, I realized I had overlooked the geometry of the MOSFETs on the finished PCB, so it didn't fit in the enclosure. Meanwhile, only 2 of the 3 channels on my first attempt worked properly, so I had a second round of PCBs made. This time I used surface mount parts, so I also had a solder mask made. This time would be different. Upon receiving delivery from DigiKey, I realized the 0402 resistors I bought were so small they're almost invisible to the naked eye. It was challenging to seat them in place on the board without losing them in the wind. I definitely lost at least one to just exhaling. With everything in place, I blasted the board with my heat gun to wet the solder. I also definitely melted some parts of the work pad. This inspired me to buy one of those third-hand tools. This worked much better. Now just a simple continuity check, and one of the resistors didn't seat properly. After a bit of manual work with the soldering iron, it seemed to connect properly. It turns out it hadn't, so when I inserted the JST sockets on the board, I covered the resistor, making it impossible to fix without desoldering the socket. This time, 2 of 3 channels worked, and the third was just completely off. So I made another one. SMD parts are super cheap, so I had bought 100 of everything I needed anyway. I had a similar problem the second time. One of the resistors tombstoned, and I had to do some difficult precision work with the iron. This time I checked the laser pins with everything plugged in to make sure the signal looked right. With every channel functional, finally, I assembled the whole mess for a quick slow-mo video. You know, the purpose of this project is to support the next phase, really, where we experiment with different designs of propellers and helicopter rotor blades. I want to be able to visualize the flow as precisely as possible. By switching the lasers, we can achieve visualization of multiple planes in space. It's a little bit disorienting to watch, but the results can be really amazing and informative. So we'll have a lot of fun with those, I promise. Remember, when mistakes are welcome, growth is guaranteed.